All right, so this is June 2019, question 9b, and it says the diagram below shows a quadrilateral PQRS where PQ and SR are parallel. So these two lines are parallel. Let's put that in. That's how we indicate parallel lines. SQ is equal to 8 centimeters. Angle SPQ is equal to 90 degrees. Angle XQR is equal to 82 degrees. And angle QSR is equal to 30 degrees. We're to determine the length PS. Alright, so let's call PS X. Alright, so the first thing I could say that this angle here, I'm going to call it theta. I could say that theta is equal to 30 degrees. There are alternate angles. Theta is equal to 30 degrees. There are alternate angles. Now, this side here is opposite to that 30 degrees. And the 8 centimeter, which is in front of the right angle, is the hypotenuse. Now, the ratio that includes opposite and hypotenuse is sine. So this is 30 degrees. So I can say that the sine of 30 degrees is equal to opposite x over the hypotenuse, which is 8. If I have one fraction is equal to one fraction, I would cross multiply. So 1 times x is equal to 8 times the sine of 30 degrees. So x, which is the length PS, is equal to 4. The lengths are in what? Centimeter. Is equal to 4 centimeters. So PS is 4 centimeters. Alright, next we're asked to determine the length PQ. So let's identify it. It's called PQY, and Y is adjacent to the 30 degrees. So this is adjacent. So the ratio that includes adjacent and hypotenuse is cosine. So I can say that the cosine of 30 degrees is equal to adjacent Y over the hypotenuse, which is 8. If I have one fraction is equal to one fraction, I would cross multiply. So I have Y is equal to 8 times the cosine of 30 degrees. So the length here is, so the length Y, which is PQ, is equal to 6.93 centimeters. Alright, and then lastly, we're asked to now determine the area of the entire shape, the area of the quadrilateral. Alright, this quadrilateral is actually this quadrilateral is actually a trapezium because they have two parallel sides. So it's a trapezium. Alright, so in order for me to determine the area, the area for trapezium is area of the it's half the sum of the parallel sides times the perpendicular distance between them. We have the perpendicular distance between them. I need to know the length of this side, which I'm going to call Z. Once I know the length of Z, I can determine the area of this shape, the area of PQRS, which is a trapezium. Alright, first of all, I think I'm going to have to use the sine rule, because for this triangle over here, triangle SQR, I know two angles on one side, so that's a condition for applying the sine rule. Alright, so let's start off with what this angle is. Let's call it alpha. Alright, and alpha would be equal to 180 minus So let's start out by saying that alpha is equal to 180 minus minus 82 plus 30. So it's 180 minus 112. So this is 68 degrees. All right. So 68 degrees is the side that is um, opposite to the 8 centimeter. So using sine rule, I can say that Z. All right, let's go back to our diagram just so it should be clear in our head. Z, which is this side, is opposite. Z is opposite to the 82 degrees. So I can say Z over the sine of 82 degrees is equal to the 8 over the sine of 68 degrees. All right, so I'm going to bring this up here and say that Z is equal to 8 sine 82 degrees divided by the sine of 68 degrees. So Z, which is SR, is equal to Z, which is SR, is equal to 8.54 centimeters. Now, the area of PQRS, area of PQRS would be equal to a half the sum of the parallel sides, which is the parallel sides are 6.93 plus 8.54. All right, so sort of run out of space. So it's equal to a half the sum of the parallel sides, which is 6.93 plus 8.54 times the height, which is PS, which is 4 centimeters. So this is times 4 centimeters. So this would be equal to the 2 is going to cancel the 4 2 times, so it's 2 into 6.93 plus 8.54, and if you could just put that in a calculator and press equal, the area is going to come out to be 30.94 centimeters square. So the area of PQRS is equal to 30.94 centimeters square.